Welcome back. It's day 9 of 100 Days of Code. And today we're going to be learning more about Python dictionaries and nesting. And by the end of today, you will have built a silent auction program. We all know that there are auctions where everybody bids and you can see everybody else's bid, and the auctioneer gets you to bid higher and higher values. Now, there's also a type of auction called a silent auction, where everybody bids silently and no one knows the other person's bid until at the very end of the auction, where the highest bid is revealed. That's what we're going to be building. And if you want to check out the final program, then you can go to blind-auction-completed.apparray.repl.run. And here you'll not only see this amazing gavel built out of ASCII, but also the secret auction program. So here's how it works. Let's say that I'm going to be the first person logging onto the program. I'm going to give my name and my bid. Let's say I'm going to bid $53 for this item. And once I'm done with my bid, it asks me whether if there are any other bidders. So if I type yes, then the screen clears and I can hand over the laptop to the next person who's going to make their bid. So let's say there's James who's going to bid even less than I did. And then he's going to make way for the final bidder, who is going to bid $121. So now at this stage, if everybody is done, then we type no, and it's going to now tally up all the bids and figure out who bid the highest and give us a winner, printing out the winner is Ginny with a bid of $121. There's a number of places that you could use this if you were auctioning some piece of art, or if you're trying to outbid your brothers and sisters on who gets to go on the trampoline, or if you're trying to start an auction with your friends or co-workers. The silent auction has many, many uses. All right, in today's lessons, we're going to be focusing mostly on the Python dictionary. But in addition, we're also going to look at how we can nest, say, lists inside lists or dictionaries inside dictionaries, and also mixing lists and dictionaries as well. Once you're ready, head over to the next lesson and let's get started with the day. All right, so the first thing I want to talk about is dictionaries in Python. Now, dictionaries in Python work kind of similarly to dictionaries in real life, right? So if you were to look up a word in the dictionary, say the word code, then you might find the definition as something along the lines of program instructions for the computer. And dictionaries are really useful because they allow us to group together and tag related pieces of information. The way I like to think about dictionaries is in the form of a table. Every dictionary has two parts to it. On the left-hand side is the key, and that is the equivalent of the word in the dictionary. And then it's also got an associated value. That would be the equivalent of the actual definition of the word. Now, let's say that we took this very simple table of definitions of programming words that we've come across so far, and we go ahead and we try to convert it into a dictionary. How would we do that? Let me firstly drop the last two rows, and let's just start with the first one. The first thing we want to do is we want to create a dictionary. And to do that in Python, this is what the syntax looks like. We have a set of curly braces, and everything that's inside the curly brace is the content of our dictionary. The key goes first, followed by a colon, and then followed by the value. In our table, we've got this word bug, which is the first key, so we can replace that over here in our dictionary. And the value that's associated with this key is the definition for a bug. So an error in a program that prevents the program from running as expected. That becomes the value and can be replaced here after the colon. So now we've created an actual dictionary using Python code. What if you wanted to have more than one entry in your dictionary? Well, you would separate each of the key value pairs using a comma. And then you can continue adding key and value pairs until you get to the end of your dictionary. All right, let's take a look at dictionaries in action. If you head over to the day 9 start code file and go ahead and fork your own copy to work alongside me, then you can see that in here I've already added the dictionary that we were defining earlier on, and I've stored it inside a variable called programming dictionary. Now currently I've only got two entries in this dictionary, the definition for bug and the definition for function. Now the first thing I want to highlight is when you create a dictionary that has more than one element, such as in this case, then you want to take care to format it properly so that it's more easily readable. So what you'll see Python programmers do by convention is they will start off the dictionary with the open curly brace at the top, and then every subsequent entry is indented by one indent. And then at the very end of that entry, there's a comma, and then we hit enter so that the next item goes on to the next line. And finally, the last curly brace should go at the very beginning, in line with the start of the dictionary. And another thing that's quite nice to do is to cap off all entries in your dictionary or list with a comma. This means that if you needed to add more items into the dictionary, you can simply just hit enter and continue typing the next thing. And if we wanted to add another entry, it's as simple as adding in the key, a colon, and then the value. And to cap it off, again with a comma. So now our dictionary represents exactly the same data as we saw in our table over here, with a bunch of key value pairs and a total of 3 entries. Now, the next thing I want to do is, what if I wanted to retrieve an item from the dictionary? Because we know that if we had a list, what we would do is we would use a set of square brackets, and then we would give the index of the item that we wanted. So the item at index 0 or 1 or 2, and so on and so forth. Now, for dictionaries, it's kind of similar in terms of syntax, but the only difference is that dictionaries have elements which are identified by their key. If we wanted this piece of information, for example, then all we have to do is tap into the dictionary and then add a set of square brackets, and inside the square brackets, we're going to provide the key. So here, the key is a string, and it's the string bug. So let's go ahead and put bug in here. And now if I go ahead and print this, then you can see that is going to give me the value, which is an error in a program that prevents the program from running as expected. Now, it's really, really important that you make sure that when you're fetching something out of a dictionary by its key, that you actually spell the key correctly. A really, really common error is when you're trying to retrieve something out of a dictionary and you've just made a very simple typo. So instead of U, I'm typing O here, and you'll see we get an error. And the error tells us that it's a key error referring to this particular key, and it highlights this line 7 where we're trying to retrieve something out of this dictionary by this key. Basically, it's telling you that this key doesn't actually exist and it can't be found, so it doesn't know what it is that you want. Remember how when we had lists and when we tried to retrieve something that was not inside the list, so for example, this particular list at index 4 doesn't actually exist because this is 0, 1, 2, 3, and 4 is actually not a piece of data inside this list. Similarly with dictionaries, if we try to put in a key that doesn't exist, then we get this key error. Now, another common pitfall that students fall down into is they don't actually use the correct data type. So, for example, if when we defined this dictionary without putting a string around each of these keys, then it's going to error out and it won't even let us run. It's going to tell us undefined name bug because it thinks that this is a variable that you've declared somewhere, but it's not. In fact, what you wanted are these strings for keys. And so when you have a key that is a string, when you're trying to retrieve the data from that key, you also have to make sure that you provide the key in its actual data type. So for example, if this was just a number, say 1, 2, 3, then of course all you have to write in here is just 1, 2, 3. and it would know that this piece of data is what you wanted. So that's how you retrieve items from a dictionary, by adding a square bracket and then giving it the key. And it will look for the key inside the dictionary and give you back the value. Now, what if you wanted to add a piece of data, such as that loop that we had earlier on, but you want to do it programmatically? So instead of doing it when you were defining the dictionary at the beginning, what if at some later stage in your program you needed to add a new entry? Well, to do this, it's also really simple. All you have to do is to tap into the dictionary, which is called Programming Dictionary in our case. And again, using square brackets, we define the key. The key I'm going to add is our loop. And then after a equal sign, I get to assign the value. So in my case, the value is going to be the definition for a loop. And now when this line of code is executed and we go ahead and just print the programming dictionary after this has happened, then we'll see that it's actually different from what we had before. So let's hit run, and you can see that previously we had a programming dictionary that had only 2 items, bug and function. And after this line 10, where we print our programming dictionary again, you can see it's now got 3 items, bug, function, and loop. Now, very often when you're writing code, it can be really helpful to start out with an empty dictionary. Just as you saw previously, you could create an empty list by simply having a set of square brackets with nothing inside. You can also create an empty dictionary by simply creating a set of curly braces with nothing inside. And then at a later stage, you can add to your dictionary by using this method that you saw here. Now, on the other hand, you might actually want to wipe an entire dictionary. Here, I'm creating a new empty dictionary by creating this pair of curly braces with nothing inside. But I can also wipe an existing dictionary by simply doing the same thing. We know that this dictionary, programming dictionary, has 3 items in it, but on line 17, I'm going to say programming dictionary equals empty dictionary. And now if I move this print statement down here, then you can see that when it prints out, it's actually going to be completely empty. That can be really useful if you wanted to clear out a user's progress, or for example, if a game restarts, then all the scores and stats will probably have to be wiped empty. So this is one way that you could do that. Now, this method of tapping into a dictionary, using the key to fetch the relevant item from it, and then doing something with it, goes beyond just adding. You can also use this to edit an item in a dictionary. For example, let me go ahead and comment out these 2 lines of code so we don't wipe our programming dictionary. And instead, I'm going to tap into the programming dictionary and I'm going to fetch the item that has a key of bug. And I'm going to redefine its value. So currently it should be an error in a program that prevents the program from running as expected. And I can prove that if I just wrap this around a print statement. If instead I wanted this to be a different value, then I can simply use the same syntax as I did for adding new items. But in this case, I'm actually editing this entry because it's going to look through the dictionary, find a value with this key, and then assign it to whatever I put on the right-hand side of the equal sign. Now, on the other hand, if it finds nothing with that key, then it's going to create a new entry with the value again on the right-hand side of the equal sign. Now, let's say that a bug is instead a moth in your computer. Now, if I go ahead and print my programming dictionary once more, then you can see that the definition for our bug has now just been changed. The final thing with regards to dictionaries that I think is really, really useful is how you loop through a dictionary. And using your knowledge from lists, you might think that to loop through a dictionary, you would, let's say we're using a for loop, and we say for thing in programming dictionary, let's go ahead and print this thing each time. Here's a good moment to play computer and think, what do you expect to be printed? So let's comment out all the other print statements so we don't get confused. And when I click run, what do you think will be printed? All right, is that what you expected? Because it certainly wasn't what I expected when I first learned Python. I thought it would give me each of the items in the dictionary with its key and its value. But instead, this code actually just gives you the keys. Now, of course, once you do have access to the key, instead of thing, I should actually really say for key in Programming Dictionary. If I wanted to print the key, then of course I could just write print key. But if I wanted to get hold of the value, I could equally just as easily tap into my dictionary, use the square bracket, and pass in that key. So now when I hit run, you can see it's giving me first the key from this line, and then secondly, the value based on this line. I'm using that retrieval code in order to get the value. Of course, remember that you can get access to all the code that I'm writing here by looking at the end code of the day that you'll find on the course resources list. And if you want to, have a quick review of everything that we've gone through so far, because a lot of this knowledge is going to be tested in the next lesson, where we do a coding exercise that will really solidify everything you've learned in this lesson so far. So for all of that and more, I'll see you on the next lesson. All right, so hopefully everything we've learned in the last lesson made sense, and you're ready to put your knowledge to the test by completing the first coding challenge today. And what you're going to be building is a grading program. So if you take a look at the day 9.1 grading program Replit coding exercise, you'll see that to begin, I've already created a dictionary with a bunch of student names and their test scores. Now, without changing any of the code above here or below here, I want you to write a program that will be able to convert these scores into a grade. So the grading criteria is over here in the instructions. So if the student scores above 91, then they'll get the grade outstanding. If they score above 81, they get exceeds expectations and then acceptable. And then finally, everybody scoring 70 or lower gets the fail grade. Essentially, what you're going to be doing is creating an empty dictionary from scratch, which is going to be called student grades. And you're going to write some code so that each of the students are represented inside this new dictionary. And instead of having scores as the values in that dictionary, you're going to have the grades that correspond to the scores that they got. So have a read through the instructions and the hints if you need some help. But once you're ready, go ahead and pause the video and give this a go. All right, so to begin, let's first tackle this to-do one. Let's create a new empty dictionary called student grades. And the student grades has to be spelled exactly the same as you see here, because otherwise this print statement will not work. Student grades is going to be an empty dictionary, which, if you remember from the last lesson, we said it looks like this with two curly braces and nothing inside. Now let's move on to to-do number 2. So we're going to write some code below so that we actually add the grades to this student grades dictionary. And we, of course, can get those grades by looking at each of the students' scores. How can we do this? Well, we're probably going to need a for loop because there's lots of items in this dictionary. Let's go ahead and loop through this student scores dictionary. And I'm going to call each of the items the student, because remember, when we have a for loop looping through a dictionary like we are doing here, each of the items that gets picked out is actually the key rather than the whole item. So again, we talked about this in the last lesson, but hopefully this should really make it clear. But even if you didn't know, you could always, of course, just print it, right? So if we go ahead and use the for loop and print it, you can see we get all of the keys from this dictionary when we're looping through it. So for each of the students, we want to get hold of their score. We can calculate the score by getting hold of the value using this key from this dictionary. And to do that, if you remember, is tapping into the dictionary, adding a set of square brackets, and then giving it the key. So in this case, it's going to be each of the student names. And once we've got hold of the score, well, then we can use our if statement to check, well, if the score is greater than 90, so anything above 90, then that means they're going to end up with outstanding. Now, this is the part where we add a new entry to this student grades dictionary. So let's tap into the dictionary, use a set of square brackets again to give it a key. And the key, of course, should still be the student name, which comes from here, which is going to be the same as this. Then we can add a equal sign and followed by the value, which is going to be outstanding. So now we can repeat this process for the rest of these grades. Everybody who scored above 80 but not above 90, so remember that this if statement, once triggered, will skip all of the rest of the elif statements. And then if they scored above 70, they would get acceptable. And finally, for everybody else, which means they scored lower than 70, then they're going to end up with a fail grade. Now, it's really important that if you want the tests to pass, that each of these strings has to match what you see over here exactly. Now that we've done all of this hard work manipulating our dictionary, it's time to actually go ahead and run our code and see what we get. So now our code has converted each of these scores to the corresponding grade. Harry exceeds expectations because his score is between 81 and 90. Ron gets acceptable because it's between 70 and 80, and so on and so forth. Now, did you manage to get it right? Or did you have any problems working with dictionaries? Now, if you go beyond this lesson, I'm going to assume that you're comfortable with editing dictionaries, adding to it, creating new ones. So if you're not yet fully there, then I recommend just going back to the last lesson and just reviewing it once more. Once you've done that, head over to the next lesson and we're going to talk more about nesting in dictionaries and lists. For all of that and more, I'll see you there. Now that we've seen lists as well as dictionaries, I want to talk about a concept that you often see in both of these collection types, and that's something called nesting. Now, if we imagine a list or a dictionary being something like a folder where lots of things can be stored inside it, then nesting lists and dictionaries is just a matter of putting one inside the other. For example, here's a dictionary that is very simple. It's only got one key value pair. Now, we know that we can add multiple key value pairs into the same dictionary by just adding a bunch of commas to separate them. Now, what if instead of having a simple value like a string or a number, I could also put a list as a value as well? Similarly, I could also use a dictionary as a value. In this case, we've got a list as the value for key, this first one, and we've got a dictionary as the value for key 2. Notice how this is a list and a dictionary nested inside another dictionary. The structure gets a little bit more complex, but it gives us more flexibility when we're trying to store more complex pieces of data. Coming back to our code, let's go ahead and create some sample dictionaries to see what this actually looks like in real life. For example, this could be a dictionary that contains the country as the key and the city, that is the capital, as the value. So for France, that's Paris. For Germany, that's Berlin. This is a very simple dictionary that you've seen already. Now, if I wanted to nest a list, in a dictionary, then I would be able to represent even more complex data. For example, if I had a travel log where I was going to collect a dictionary of all the cities I had been for each of the countries I've traveled to. So, for example, if I had traveled to France and I wanted to say that I've been to multiple cities, I can't simply just say Paris and then Lille, Dijon. That doesn't really work because each key can only have one value. The only way that we can make these three pieces of data one value is by turning it into a list, like so. So now in our travel log dictionary, as represented by the curly braces, we have one key value pair, and it just so happens that the value in this case is a list. And of course, you can go on and add as many entries as you would like, and still preserving this kind of structure of key being a string and the value being a list. Now, this idea of nesting isn't limited to dictionaries, by the way. You could also just nest a list in a list. So you could have a list which is A and then B, and then the third item just happens to be another list which has C and D. This is perfectly valid Python code, but it's not quite as useful as nesting a list in a dictionary or a dictionary in a dictionary because of the way that data is structured. Now, what if you wanted to nest a dictionary in a dictionary? Let's say that we wanted to expand our travel log. And instead of just storing the cities that I've visited in each country, what if I wanted to also keep track of how many visits I've made to that country? Or what if I wanted to actually label what this piece of data is? Because at the moment, it's kind of like, here's a bunch of cities that's associated with a country, but it doesn't really describe this list. And I'd like to give this to you as a challenge. Have a go at changing the France entry so that it contains another dictionary. For the nested dictionary, use the key cities_visited, and for the value, you can keep the list of Paris, Lille, and Dijon. Pause the video now and see if you can get that to work. Alright, so here's the solution. By nesting a dictionary, we can label the Paris, Lille, and Dijon list as cities visited. All I need to do is create the string cities visited and add a colon after it. But there's one more step. We have to add a pair of curly braces so that France is associated with a single value, namely our nested dictionary. Now we have a dictionary of the travel log, all the countries I've been to, and each country has a value that is a dictionary in itself. And it can store multiple pieces of data, including the cities I've visited in that country, as well as things such as the total number of visits, which in this case would have a string as the key and a number as the value. Now have a go at creating your own travel log or modifying the second part of the travel log so that you also have a dictionary nested in a dictionary. And you're able to represent something like this: the number of cities you visited in a list and another additional piece of data if you wanted to. And hopefully you would have done something similar to this. And so now our data structure is such that we've got a list nested inside a dictionary, which is in itself nested in another dictionary. Now that we've seen nesting lists inside dictionaries, dictionaries inside dictionaries, the last thing I want to show you is nesting a dictionary inside a list. So we could basically have multiple dictionaries inside a single list. So remember that lists are ordered and they're accessed by the positions inside the list. So this dictionary would be the item at index 0, this one at index 1, and so on and so forth. Whereas inside a dictionary, the items are accessed by their keys, like this France or Germany. Now, I want to do the last type, which is nesting a dictionary in a list. And I'm going to be working with the same travel log that we had previously, but I want to change it so that instead of having this being one giant dictionary with key value pairs, I want to change it so that each of these entries are a dictionary in itself. Instead of having France be the key of this dictionary here, I want to turn it into its own key value pair. Going inside this dictionary, I'm going to create a new key, which is called country, and then put France as the value for that key. So now I have an entire dictionary that has 3 pieces of data: the country visited, the cities visited, and the total number of visits. Let's do the same for Germany as well. So now you can see we've got 2 dictionaries. And instead of holding these 2 dictionaries inside a dictionary, I'm going to change it so that it's now a list. I'm going to turn these curly braces into square brackets, and this way we can add as many of these dictionaries inside the list and iterate through them if we need to. When we've been creating dictionaries that only have 1 or 2 key value pairs, we've kind of just kept it all on one line. But once you've got more and more key value pairs in the dictionary, it's usually a good idea to go ahead and separate out each of the entries, like what I'm doing here. Now it's a little bit easier to see that we have a list which contains 2 items, and each item is a dictionary. Each dictionary has 3 key value pairs, and they all contain different types of data. The first one has a value, which is a string. The second one holds a list, and the third one holds a number. The data types inside a dictionary can be completely mixed up if you want it to. But what can't change is you still need a key and a value separated by a colon. Now, the only downside to this is you want to make sure that you're actually aware that later on when you try to pull out the number of visits, it's actually a number that you're working with rather than a string, or when you're trying to get hold of the cities visited, it's a list rather than a dictionary, for example. So now that we've seen various different types of nesting, it's time for you to actually really understand this and get to grips with this concept by completing a challenge yourself. In the next lesson, I've got a coding challenge for you based on this travel log, and you'll need to use what you've learned so far to be able to complete it. So for all of that and more, I'll see you on the next lesson. Now if you head over to Replit, click on Day 9.2 Dictionary in List, this coding exercise should appear. And you'll see that we actually have the same list that we created at the end of last lesson. This is a list called Travelog, and it logs the countries that we've been to, how many times we visited it, and the cities that we visited while we were there. This is a list of dictionaries which contain a list of cities. There's some heavy nesting going on here. Now, your job is to make sure that this line of code on line 20 and 21 actually work. In order to make it work, you're going to have to write a program. So it's going to be a function that's going to go somewhere in here, and you're going to get it to be able to add new countries, the name, the number of visits, and the cities that you've been to, so that it gets populated in the travel log. And when we print travel log at the end, it should show us all 3 of these entries. So remember, the goal is not to modify this directly. In fact, I don't want you to touch this part at all. Instead, it should be your function that's going to somehow go through this travel log and add these new pieces of data. Have a think about how you're going to achieve this, and then pause the video and give it a go. All right, so because we've already defined the name of the function here, in order for our code to actually work and for the tests to go through, we also have to create the function using exactly the same name. So it's called add new country. And then the inputs that it's going to take are the country visited, the times visited, and finally the cities visited. So now that we've created our new function, the next job is to figure out, well, how do we add these pieces of data that's going to be passed in to these parameters and get that into this travel log? So the first thing you need to notice is each of the entries inside the travel log is a dictionary. In order to add to that list, we should probably start off by creating a new dictionary that has all of these pieces of data in it. For example, we could create a new dictionary called New Country, which is an empty dictionary, and then we can add each of these pieces of data to the dictionary. So we could say New Country, square brackets, and then we give the key that we want to add. So in this case, it would be the key country as a string. And the data or the value that's going to go in that is going to be whatever gets passed into country visited. So now all we have to do is repeat the process for the other keys in the dictionary. So visits is the next one, and that's going to be set equal to the times visited. And finally, we're also going to populate the final key, which is cities. And that is going to be equal to the cities visited. Now, at this point, if you were to print out New Country, you should see a dictionary with 3 key value pairs. And the keys will always be the same, but the values will depend on which arguments were passed in when this function was called. So once we have that new country, then we can actually take our travel log. And remember that the travel log is actually at its base a list. So instead of adding to it like we have been doing when we're using a dictionary, in order to add to lists, if you remember, you should probably use the function append. And inside here, we can add a new item to our list. And that new item is, of course, going to be this dictionary called New Country. So now if we go ahead and click run, then you can see when travel log gets printed on now line 27, it's now got 3 entries. The first entry is the dictionary for France, the second is the dictionary for Germany, and the last one is the dictionary for Russia. We have now a list with 3 items, each being a dictionary, each with a nested list inside as well. So if you wanted to, you now have a way of keeping track of all the places you've visited. And later on, as we start building out more complex apps and web applications, then you can easily see how logic like this might be really useful if we were building a real-life website for tracking our travels. Have a play around with nesting dictionaries and lists. And once you're happy that you've understood everything that's going on, then head over to the next lesson and we're going to start tackling our final project. All right, so now that you've learned all about dictionaries, we're going to put all of that knowledge to test and to use by building a blind auction program. So here's the program. When you first run it, it's just going to show you the logo art and maybe a line that tells you what program you're in. And then it's going to ask you for your name. So let's say we have 3 bidders, right? So first go, I go to the computer, I type in my name, I type in my bid, and I hit enter. It asks me if there are any other bidders. I look around the room, I see 2 other colleagues, so I type yes. And now it clears the entire screen so that other people can't see what my bid was. So now I leave the computer and my colleague comes over, they type in their name and also their bid. And again, they look around the room and they see there's 1 other person who wants to bid, so they hit yes. Again, it clears their bid, and finally the last person makes their bid. At this point, everybody has bid, so she's going to type no. And it's at this moment when our program is going to work out who has made the highest bid and print out who the winner is and what their bid was. This way, instead of competing with each other on bids, we actually all just give the highest price we're willing to pay, and this is known as quite an efficient way of making a bid. And you see that a lot in, say, the construction industry and government, etc. The important thing in this program is you're going to start out using the Blind Auction Start Replit. And the first thing you'll notice is that I've already imported this function called clear from the Replit module. And you can basically call this function clear whenever you want to clear the output, just as you saw here. Whenever we typed yes after being asked if there are any other bidders, that just calls the clear, and then it gets rid of everything that's in the console. In addition, we've also got the starting art of the gavel logo, which you're going to put into the program. And the most important thing of all is that I want you to create a dictionary so that each person's name will be the key and their bid will be the value. And this dictionary is going to contain many of these key value pairs. And at the very end of the program, when everybody's done with bidding, then we're going to loop through that dictionary and figure out who has made the highest bid. If you want, this is a good time to analyze this completed project and see if you can create your own flowchart using something like Draw.io that I've shown you before, or just take a piece of paper and a pen and draw out your flowchart. Now, if you want a hint, then you can head over to the course resources and you'll get taken to the flowchart that I've created for this program. So spoiler alert, I'm about to show you that flowchart. So if you don't want to see it and you want to create your own because it's a relatively simple program, then pause the video now and complete the challenge by yourself. Now, for everybody else who's still here, I want to show you this is a flowchart I've created to represent this program. So we start at the beginning, we first show the logo from that file art.py, and then we ask for a name input, we ask for their price. Now we're going to add the name and the bid into a dictionary with the name as the key and the bid as the value. Now, once we're done with that, then we get to ask the user for another input and see if there are any other users who want to bid. So if they answer yes, then we're going to clear the screen and we're going to go back to here, ask for another name, another price, and so on and so forth. But if they say no, everybody's done with bidding, then we're going to call some sort of function that we have, which is going to loop through our dictionary that was created here and find the person who had the highest bid value and then declare them as the winner and print out their bid. So it's a relatively simple program, at least compared to other things that you've built so far. So this is the time to pause the video and give it a go. I'll see you on the next lesson where we'll go through the solution together. All right, so how did you get on with today's project? Hopefully it went really well and you're just here to see how I did it. As I mentioned before, it's really useful when you're trying to create a large project to break it down into smaller pieces so that you can tackle each of the pieces one by one. And a great way of doing that is by creating your own flowchart. So as I've shown you before in the end of the last lesson, this is the flowchart that I've created for this particular program. And I'm going to follow it step by step to create this final blind auction program. The first thing we're going to do is we're going to show the logo from this file art.py, and notice how this logo is stored inside a variable called logo. So the first thing we have to do is to fork our own copy of the starting project, and then we're going to look inside the art.py module, and then we're going to import that logo. So now I can go ahead and print my logo, not Lolo. So that's the first step done. Next, we're going to ask for a name. So that's going to be in the form of an input. So let's go ahead and create a variable called name, and we're going to set it to be an input. And the input is going to say, what is your name? So they're going to type in the name, and that's going to be stored inside this variable. Now, the next thing we're going to do is ask them for their bidding price. We'll save that inside a variable called price, and we'll create another input to ask them, what is your bid? And at the end of this, I'm going to add a $sign, just so that when they are typing their bid, they'll see this line. And when they start typing, the cursor should be about here, so they can see the dollar symbol before their price. So now we're down to here, and we have to add our name and our bidding price into a dictionary. Let's go ahead and create it up here, and we'll call it bids, and it's going to start out as an empty dictionary. And then later on, once we've got the name and the price, we said that the name was going to be the key and the price was going to be the corresponding value. To add a new entry to our bids dictionary, we specify the dictionary, we add a set of square brackets, and then we add the key. The key is going to be the name, and the value is going to be the price. So we would write it like this. Now we get on to the slightly trickier part. We're going to ask if there are any other users who want to bid. And if the answer is yes, then we're going to clear the screen and we're going to loop back to where we're asked for the next name and the next bid price. How do we achieve this? Well, we can put this into a while loop. Let's go ahead and indent this. So I just typed command and then the right-sided square bracket, or on Windows it will be control and the right-sided square bracket. And then we can wrap this into a while loop. If we had some sort of variable that would keep track whether if the bidding is finished, so let's call it bidding finished. And of course it starts out being false. Now, while bidding is not finished, so while not bidding finished, so basically while this is still false, then we're going to keep running this until forever. But of course, we need a way to stop this. So we're going to create a new input where we ask the user, are there any other bidders? Type yes or no. This way, we get to get an input, which is going to be either the word yes or the word no. And we can save this inside a variable called maybe should continue. So this way we can check this variable and we can see, well, if should continue is equal to no, well, in that case, that's when we're going to flip the switch and change this bidding finished variable to true. So this means that when we get to the end of this block in the while loop, then when it checks this bidding finished, it's not going to continue to loop anymore. Now, on the other hand, if should continue was yes, or in fact any other value, then we can keep continuing and we don't actually have to change this variable because it's already false. Now we have our code looping, which means that unless the user types in a no at the very end and bidding becomes finished, this is this path. Otherwise, then we're going to keep going through all of these lines of code, which is basically all of this, until we get to the point where this switch actually gets flipped. So if you notice that if the user actually answers yes, then we want to clear the screen before we repeat the loop. That means we can check to see, well, elif should continue is equal to yes. Well, in this case, we're going to call that clear function that I showed you in the hint at the very beginning. So this function comes from the Replit module and allows us to clear the output in the console so that the previous name and bid gets cleared off the screen and it leaves a fresh start for the next user. The last thing we have to do is to actually address this, right? So when they answer no, they get taken out of the while loop, but we still have to find the highest bidder from our dictionary and to declare them as the winner. How do we do this? Well, let's put this in a separate function. So we could create a new function called find highest bidder. And this is going to get the bidding record as the input. So this will be the dictionary that represents all the bids, the names and the values. I think it's easier if we can visualize what this bidding record might look like. So we know it's a dictionary of key value pairs where each key is a name and each value is a number. So let's say we had only two bidders, Angela and James. Angela bid $123, James bid $321. So we can see who's clearly going to be the winner here. But how do we get our code to figure that out? We need to somehow loop through this dictionary, right? Which is called bidding record. We know that we can use a for loop to do this. So we can say for each bidder in the bidding record, not bidden record. And this is a good point to remember that when you use a for loop on a dictionary, instead of looping through each item in the dictionary, like each of these key value pairs, it actually loops through each of the keys. And we covered this in the very first lesson of today, where we talked about how the for loop works when we're looping through a dictionary. Now we're going to get hold of each of the bidders inside this dictionary. So what do we do with it? Well, we want to use the key to get the value. Let's take the bidding record and pass in the key, and this should give us the value. So now we can actually save this inside a variable, which I'm going to call bid amount. So the first time this for loop runs, the bid amount is going to equal to 123. And the next time the for loop runs, the bid amount is going to be equal to 321. If we had some sort of way outside of the for loop that keeps track of the highest bid, well, then we could use this number to check against the current bidding amount. We can use an if statement to check, well, if the bid amount is greater than the highest bid, well, in that case, then the highest bid becomes the bid amount. So what this means is that we start out with a 0. The first time the for loop is run, the bidder is going to be equal to Angela. The bid amount is going to be equal to Angela as the key passed into this dictionary, which is going to get us the value, 123. If 123 is greater than 0, well then this highest bid is now going to become 123. The next time the for loop runs, the bidder is now James, and the bid amount is now 321. Now we're checking if 321 is greater than the highest bid. Remember, this in the last round got set to 123, so this is going to be true, and this means James's bid, 321, is now going to be the highest bid. In addition to keeping track of the highest bid, we can keep track of the winner. If this is indeed true, if the current bidder has the highest bid, well then at the same time as setting the highest bid, we should also set the winner to the key, so the current bidder. And once we've gone through this for loop and we've looped through all of the records in the bidding record, well then finally we can actually print the winner is the winner that's stored in this variable. And we're going to say they won with a bid of, and let's add a $sign, and then we're going to pass in the highest bid. Now we can turn this into an F string, and it will use both of these variables, which is storing the highest bid and the winner's name, to print out who the winner is. So down here, when should continue is no, going down this path, we can now print and declare the winner. In addition to saying that bidding finished is true, we're also going to call that function find the highest bidder and pass in all of the bids that we have been keeping track of over here. Now, just before we run our code, let's go through each line and make sure that everything looks all right. Firstly, here where it says, what is your name? Maybe we can add a colon and then a space so that the user starts typing here. Then it asks, what is your bid? We can add a colon as well, and the user will start typing after the $sign. Now, I can already see a problem that's actually going to happen because of this line 23. I wonder if you can spot the issue here, especially if you think about what we're going to do with this price later on. But I'm going to add one more new line here, and then I'm going to run the code, and we'll see what actually happens. So now let's go ahead and run the code. And you can see our gavel printed, and then it asks us for our name. So I'm just going to put my name, and then 123, and then one other bidder who's going to be James, 321. And now if I say no, there are no more bidders, see what happens when I hit enter. I get a type error, and it tells us that the greater sign is not supported between instances of a string and an int, and this happens on line 16. If we take a look at line 16, basically we're comparing the bid amount, which is the value that came out of the bidding record, which is what's being passed in here, and that, of course, is a dictionary where the keys are the names of the bidders and the value is the price. So what's actually happening here? Well, it's because when I took this price input in, I kept it as a normal input. Instead, it should be turned into an integer. So that way we can work with it as a number, so that when we're comparing it against, say, 0 or whatever other number later on, it can actually do the comparison. It doesn't actually make sense to the computer when you're comparing a string versus a number. That doesn't actually work. And this was covered when we talked about data types in Python. Now, if we hit run again, and we do the same thing, and when I say no, you can see that it tells me the winner is James with a bid of 321. Essentially, the hardest part of this challenge is figuring out how to loop through a dictionary and get hold of each of the bidders and each of the values and compare them historically against previous values inside this dictionary. If this function is confusing to you, then I really recommend either going over to Thonny, pasting the code in, and exploring it by going through it step by step. Alternatively, if you can't install Thonny or you don't have access to your normal computer, then you can also go to a website called pythontutor.com. And this also lets you visualize your code, although in a slightly more simplified way. If I go ahead and paste in my function, find highest bidder, passing in the bid record, let's go ahead and create a new dictionary of bids. So now we have a dictionary of bids with two key value pairs, just as we entered before. And then I'm going to call this function find highest bidder and pass in these bids. Now, if we go ahead and click visualize execution, you can see it's going to go line by line, and we can click next to see how it's jumping through this. Firstly, it's bypassing this function, creating this next dictionary. So now it's got a function stored somewhere, which is this one. It's got a dictionary called bids stored somewhere else. And now we actually get to the line which is going to execute that function. And it's going to pass over this dictionary of bids to this function. And if you step through this line by line, you can see it creating these new variables and populating them. The first time we run it, the highest bid is 0. The winner is an empty string. And the bidder in the for loop is now Angela. It's the first key from the dictionary, as it points to here. Now, if we keep clicking next, it works out the bid amount, which is the value corresponding to that key. And then it works out the highest bid by comparing whether if the current bid amount is greater than the current highest bid. So 123 is greater than 0. So when I click next, you'll see highest bid gets replaced with the bid amount. And the winner is now going to be set as Angela. The next time the for loop runs, the bidder is now James. And if I keep going through this, you can see that James actually ends up with the highest bid and becomes the winner. So now the for loop is done because it's looped through all items in the dictionary, and it's now going to print the output, which is the winner is James with a bid of 321. This is another way that's really, really helpful to visualize your code. And the other great thing is that even if while you're visualizing, there's still something you don't understand, you can actually click on this button to get live help from users across the internet. And if you want to practice your own debugging, just as we did in today's lesson, you can also click to help some of these users who are looking for help with their code. And you can practice reading code, understanding code, and helping other people with their bugs and their issues. Finally, if you want to take a look at the completed code for today's project, then as always, you can head over to repl.it/@apiary/blind auction completed. And it's important to remember that this is just one way of completing this project. There are lots and lots of other ways. But as long as you test your program thoroughly and it works in the same way, then it doesn't matter too much how you've done it. But it's important that you've absorbed the knowledge in today's lessons. And the most important of which is this concept of dictionaries, adding to dictionaries, and also looping through dictionaries. So have a look through the completed code and also have a play around with Python Tutor, which is a really great resource for your learning. And I'll see you tomorrow for more lessons on Python.